Let's finish lesson 3.6 by writing equations of higher ordered polynomials. And I apologize if you can hear my dishwasher in the background. To write equations of polynomials, we're going to follow 4 key steps. In the first step, you want to make sure to identify all real and complex roots. They may tell you what the degree is, where you should know how many roots there are, or they may give you complex roots where you know the conjugate is also an option. From that, you want to create linear or quadratic factors. From that, you'll generate your entire polynomial by foiling. Once you foil, combine like terms. Once you've combined like terms and simplified, we're ready to write our equation. Let's try some examples. Find a polynomial function p of x with a degree of 3 and given zeros 2 and 3 plus I. If we're given a degree of 3, that means we should be able to identify 3 zeros in step 1. Well, they tell us a 0 is 2, so we'll know x equals 2. And we're also given that 3 plus I is a given 0, or root. If 3 plus I is a given root, then we also know that 3 minus I is a root. That's applying that conjugate root theorem. Notice we have 1, 2, 3 different roots in step 1, and it said it was a degree of 3. So that's our first step. Step 2, create linear and quadratic factors. For x equals 2, that means as a factor, it would have to be the opposite sign. So as a linear factor, that would be x minus 2. And then thinking about, because it's opposite sign, it would cross at x equals 2 on a coordinate system. For 3 plus I and 3 minus I, we're going to apply the sum and product rule. So let's figure out what our b and c values are. Okay, so we'll do sum and product. The b value gives us the sum. If we take 3 plus I plus 3 minus I, remember the i's will always cancel out. 3 plus 3 is 6. And that's what our b value will equal. C takes a little bit more work. We're going to FOIL. All right, how about you guys FOIL? Do first, outside, inside, last. Remember that I squared equals -1 and see what you get for that constant at the end of our factor. Hopefully you got a constant of 10. I did 9 minus 3i plus 3i minus I squared. The 3 i's canceled. 9 minus -1 is 10. My quadratic factor then, if I follow my form x squared minus bx plus c, is going to be x squared minus 6x plus 10. Now those two factors should generate a polynomial function of degree 3, or a cubic function. To get that, we're going to FOIL. I'm going to take my linear factor of x plus 2. Wow, x minus 2, that would have changed things. And x squared minus 6x plus 10. Let's FOIL and see what we get. If I take x times x squared, I would get x cubed. X times -6, x would be -6x squared. And x times positive 10 would be 10x. -2 times x squared would be -2x squared. I'm going to put that right there. -2 times -6x is positive 12x. And last but not least, -2 times 10 would be -20. If I combine my like terms with my columns that I've created, we have x cubed for our lead term. -6x squared minus 2x squared would equal -8x squared. Oops, sorry about that. 10x plus 12x would be 22x. And then our constant is -20. Giving myself just a little bit more room on the right to create my final answer. The notation is p of x. Therefore, I'm going to write p of x equals. And all of our terms are already combined. We have x cubed, which is our cubic function, minus 8x squared plus 22x, it's 22, minus 20. Well, hopefully you guys can see all that in there. Let's make sure that 20 fits in there. Get in there, little buddy. There we go. All right, so x cubed minus 8x squared plus 22x minus 20. In our next example, we're kind of on our own. It says if a polynomial f of x has 4, -2, and 2 plus 3i as roots, write the equation for f of x. If we look at our zeros, I see a 4 and a -2. Those are both real solutions. They won't have conjugates. However, 2 plus 3i will have a conjugate for our zeros. So as we list out our zeros in step 1, we know x equals positive 4. We also know it equals -2. Last but not least, it equals 2 plus 3i. As is, it looks like we have a cubic function. But recognizing that 2 plus 3i will also give us 2 minus 3i, this is going to end up being quartic, which means we should have x to the 4th in our final answer. That makes step 2 unique. Instead of having linear and quadratic functions, we're going to have factors. We're going to have 2 quadratic factors. Let's group our real zeros together, 4 and -2, and then we'll group our complex zeros together, 2 plus 3i and 2 minus 3i. If we find the sum and product for each, the first one's pretty easy. The sum of 4 plus -2 is 2. The product, 4 times -2, would be -8. Therefore, the factor is x squared minus bx plus c. Well, c is negative, so minus c, so minus 8. For 2 plus 3i and 2 minus 3i, if we add them together, the 3i's cancel, and we get 4. Their product, we have to FOIL. Take the time to practice this, you guys, and you'll be really good FOILers when you're done. 2 times 2 is 4. 2 times -3 is -6i. 3i times 2 is positive 6i. 3i times -3i is -9i squared. So be careful on that last part. The 2 terms in the middle will always cancel. This will always become positive because of that I squared. 4 plus 9, or 4 minus -9, would be 13. Therefore, this quadratic factor is x squared minus 4x plus 13. Oh, I'm out of room and I haven't even done step 3 yet. Oh boy, we're going to have to move this over. Hang on. All right, hopefully you have enough room for this on either the bottom or the right-hand side, or maybe over on the left-hand side. We're not writing anything else in that column, so if you need to use that space, feel free. Step 3, we're going to take both of our quadratic factors, x squared minus 2x minus 8 times x squared minus 4x plus 13. And guess what? We're going to FOIL. Let's see what we get. If we take x squared times x squared, we're going to get x to the 4th. X squared times -4x, that will give us -4x cubed. And x squared all the way times 13 will be 13x squared. We get to do that again and again. -2x times x squared would be -2x cubed. So that goes in that second column. -2x times -4x will be positive 8x squared. Last but not least, -2x times positive 13 should give us -26x. You ready for one more round? Let's try one more. -8 times x squared would give us -8x squared. -8 times -4x should give us positive 32x. And -8 times 13 will give us -104. Oh, and I can't get that to fit. Yikes. All right, let's combine our columns. We have x to the 4th. Maybe. There we go. Oh, boy. The dishwasher noise is throwing me off. All right, we have x to the 4th. And then in our second column, -4 minus 2 is -6, x cubed. Ooh, look at this. 13x squared plus 8x squared, but minus 8x squared would give us 13x squared. All right, negative 26x plus 32x. That would give us plus 6x. And then minus 104. So I'm going to do a little cheat here and call that step 4 and identify this as f of x. Make ourselves have a little bit less work to have to rewrite that out one more time. But I'll make my equal at least look a little bit nicer. Hang on. F of x equals. We have x to the 4th minus 6x cubed plus 13x squared plus 6x minus 104. Now let's see what happens when you have no real roots, all complex. What is a polynomial of degree 4? Oh boy, a degree of 4 again. With integral coefficients, which just means there aren't any i's in our answer, and zeros 5i and 2 plus 4i. So we're supposed to have a degree of 4, but we're only given 2 specific zeros. In step 1, if we identify positive 5i as a 0 or a root, that automatically means negative 5i is also a root. Then if we say 2 plus 4i is a root, again, because it's complex, its conjugate to minus 4i, also a root. So now, just by knowing that rule, we have our 4 zeros for this function. We are ready for step 2. Step 2, let's create our factors. Since we have 4 zeros, like we did up above, we're going to create 2 quadratic factors. And I encourage you to group the conjugates together. We'll do the positive and negative 5i, and then the 2 plus 4i and 2 minus 4i. Find the sum and the product of each. When you're done, press play and we'll see if we have a match. You should have a factor of x squared plus 25 and a factor of x squared minus 4x plus 20. Notice for that first pair of complex factors or roots, the b value is 0. That means the middle term cancels out, which is nice. It gives us one less thing to FOIL, but we're ready for step 3. We're going to do a pretty big FOIL here. We have x squared plus 25 times x squared minus 4x plus 20. All right, again, pause the video, you guys. See if you can FOIL this and combine like terms. The more proficient you are at this step, the easier your homework will be. So try it and press play when you're done. All right, let's see how we ended topic 3. If you FOIL x squared plus 25 and x squared minus 4x plus 20 and combine like terms, you should end up with the following polynomial function. I identified it as p of x, but if you call it f of x, that's fine too. P of x equals x to the 4th minus 4x to the 3rd plus 45x squared minus 100x plus 500. Imagine if we had to graph this. The y-intercept would be all the way up at 500. Thank goodness we don't have to. We just created the polynomial. And that's the lesson for 3.6.